Welcome to this advanced PDE part 2. So this is second part of this course. As explained in the introductory talk in the first part of this advanced course on PDE, we are now going to see how the tools of Sobolev spaces thoroughly developed in the first part of this course will be put to use to analyze PDE. This part essentially consists of discussion on elliptic equation and little bit of semigroup theory and their application to evolution equations. As explained earlier, the theory of distributions thoroughly developed by Lawrence Schwartz in the 1940s has become the language of the modern theory of PDE. Though there were attempts before Schwartz by Leray, Friedrich, Sobolev and others to analyze some specific PDE using the concept of what we call now weak derivative. However, the theory of distributions put a strong foundation to these ideas and in a way unified them, and the modern theory of PDE was born. The importance of this subject, an important branch of mathematics with an impressive connections and application to other branches of mathematics, physics and engineering, can be gauged through the number of Fields medals and Abel prizes it has received over the years.
Okay, thank you. As mentioned in our first introductory talk about the advanced PDE part 1, there are numerous number of good books in the subject PDE, though with different contents and objectives. So you may see that various books have different contents, but it covers the basic things. The subject field has grown tremendously over the years, and there are many specialized books catering to specific classes of PDE. A beginner interested in learning the subject may find it difficult to choose the right book among these books. That's why you probably need the advice of your teachers to choose the books depending on your interest. Though learning the subject through classroom lectures is essential and very much wanted, this subject is offered for study only in a small number of institutions in our country, which is unfortunate, and thus a large number of students do not have access to such courses. In such a scenario, the online courses offered by NPTEL indeed offer a very satisfactory way of learning a subject very close to that of classroom learning. Coming to the discussion on the present course, the contents of the course, the present one and the part 1, which we have already finished, cover the modern theory of PDE at an introductory level. As mentioned, this course is not introductory, but is introductory to study PDEs or do research on PDEs. This part also is an intensive hard course, so the first time learners need to work hard in order to grasp the new concepts. In such a course, it is not possible to give explanation and or details of every step. A student need to work out all the detail by filling the gaps. This is good time to review the first part of this course in order to follow the second part and benefit from the same. So we are stressing again that if you have not done the first course, please go through it and study and work out examples and prepare well. Once you prepare well, this will be relatively easy to learn it. It is advised that students note down their difficulties while listening to video lectures and have constant discussions with us and or TS. We again stress that the subjects of measure and integration and functional analysis are essential prerequisites. In addition to this course also demands a fair knowledge of unbounded operators and semi-group theory. That's a new, slightly a different topic introduced in this. Further, we also advise the students to, through our first course on PDE is given 2 parts as NPTEL courses. though we have tried to cover some part of these two prerequisites, many gaps left the need to be filled by the students. Thus, we again stress that it is very much required to have academic discussion at every stage.
Now, coming to the course, a brief discussion about the contents. Of course, you will find these contents on the NPTEL web page also. In the first week, roughly about 6 lectures, we present a review of Sobolev spaces. So you can again look at the first part where the Sobolev spaces are thoroughly developed, and embedding theorems, and present some important inequalities not discussed in the first part. In the next 3 weeks, weak formulation of elliptic equation will be done, and an abstract variational problem, Lax-Milgram lemma, Stampacchia theorem will be discussed. If time permits, we may also discuss Stokes system. So that's a system of equations, not a single equation, and some eigenvalue problems and some maximum principles. During the 5th and 6th weeks, a review of unbounded operators, semi-groups and their generators will be discussed. In addition, Hille-Yoshida theorem, Lumer-Phillips theorem will be discussed along with M-accretive operators. They are also called M-dissipative. And then abstract Cauchy problem of first order and second order in Banach spaces will be discussed. In the last 2 weeks, the semi-group theory developed is applied to study the heat equation, wave equation and Schrodinger equation with a potential. This is a rough plan. There could be some changes as the course progresses. We very much wish the students a great success in learning this exciting subject.
Thank you very much.
Thank you.
Thank you.
Thank you.